Okay, so Mr. Bunji is going to start his lecture immediately. So I hope we are all ready with our writing materials and our laptops. So Mr. Bunji is going to be talking about data analysis for health research. So Mr. Bunji, you have the floor, please.
Okay, good evening, all.
Good
Thank you,
evening.
Mr. Samuel. Thank you, Mr. Samuel, for that wonderful experience you shared. We also look forward to that. Even as lecturers, most times you see us trying to key into what you have said. Several times we have tried. In fact, sometimes, most times we have failed, but we still have other plans, particularly for PhD to fly out there. When we are done with our PhD, we want to go for postdoc. So I see a lot
Very
of
important.
I've seen a lot of reason why I need to contact you after this lecture. So thank you very much for that presentation.
And you can see that you're volunteering effort here too.
So that's by the way. I understand today, if I have the floor, thank you for those present, for those who were able to make it to this class. And that first 15 minutes is not a waste at all. We have learned. What I have here, we are taking data analysis today. I think it's good we just go straight to the point. Because of time may not be on our side. I want to know if they can hear me and my screen is clear.
Yes, sir. We can hear you,
Okay,
sir.
okay.
Yeah, we
Okay,
can
thank
see.
you. Oh, thank you. So that will keep us at peace. So today we are looking at data analysis. And in data analysis, you remember the last class we had was wonderful. That was the last week. We collected data, if you remember your skills there. So today, we are not going to keep whatever you have learned from past lectures away from what we have now. We are supposed to connect. So the way it has been organized, you see, we started much earlier. At some point, you see sampling technique. They even started from literature review. They went down to sampling technique and then data collection. And now here we are on data analysis. Take, for instance, you have collected your data. You remember you are supposed to have been following this up. You are supposed to have been following it up and having an example with all the assignments given to you. So today, after this class, we expect you to be able to beef up whatever you learn, build upon what you have. And to the end of our presentation, you have a complete project, is some kind of demo that you have written by yourself. So put the experience into practice. Data analysis, this is our outline. In our outline, we hope to look at, this is our outline. We divide this presentation into two sections. If time permits, the first section is all the presentation we are having now. But the second section, I will prefer us, which you have been told that you get your laptop close to you. We'll just make a small hand practical exercise just to buttress what we have learned so far in this presentation. We are going to look at key terms, measurement scale, overview of data analysis, what really data analysis means, and then descriptive statistics and inferential statistics. Because when we talk about data analysis, we look at two major components, as you see in the presentation. Types of error, we need to be conscious of that. We'll talk about it a little. But remember, as we say, we have two sections. After learning this, what do? You put it into practice. There are a lot of tools that we use them today that assist us in our research. Those tools, we'll see some of the examples, and at the end of the day, we'll use one of them for analysis. Section B, of course, is a hands-on exercise, which we are going to see different exercises, of course, but the third exercise, we are going to use the computers you have. For those who have it available. But if you don't have, you still follow. I'll project the screen as we demonstrate. What then is data analysis? Sorry, Jerry, I will need to know at different intervals because I've already put my screen full. Can the students, can you hear me, please?
Yes, sir.
Okay, Jerry?
Yeah.
Thank you. I hope my network is good. It's not that of Nigeria. I have a backup of a Wi-Fi by side, the institutional data, internet. Data analysis, you see, is actually a process of examining, cleaning, and interpreting data to uncover useful insights. Of course, you remember the data you have collected. It will not make sense, particularly to those who did not collect the data. You that have collected the data, you know where you're heading to. You collected the data for a reason. But eventually, if you just drop that information on piece of paper, scattered, it doesn't make sense. Now, what do you do with that data? Assuming you have collected it from the right source, that is the target population, you have also cleaned it. The process of collecting it was well articulated to cover the entire population, like a representative of the entire population. If the data is good enough, what then becomes of the data? So data analysis is where we look at to give meaning to what you have collected. It serves as a crucial tool in decision making. Of course, you collected that data because there was a topic, there was a problem. That problem was written in form of a research topic. You set out to answer such questions which were earlier embedded in your research questions listed earlier when you started the research. Of course, you were able to list out objective of your research. So that data you have collected is going to answer, the main purpose is to answer those objectives. You remember, even you, the researcher, didn't know how it's going to end. But after analysis, you get a meaning for the data you have collected. Purpose of data analysis, of course, is to obtain useful information, irrespective of whether the data is qualitative or quantitative. Because most times when we mention data analysis, some people, your mind will now be narrowed to a 1, 2, 3, that's numbers, without knowing that, of course, there are two types of data we collect, the qualitative data and the quantitative data. But most of the times when we mention data analysis, we key our mind directly into quantitative. At the end of this research, you should know that the data you have collected, whether quanti or quali, it can also be analyzed. So we are supposed, based on that, irrespective of whether it's qualitative or quantitative, it's meant to describe and summarize such data. Remember, the data was so scattered that doesn't have meaning, but after analysis, you can be able to summarize that. It's meant to identify relationship between variables, to compare those variables, identify the difference between those variables, and forecast the outcome. Take note of these 4 items we mentioned. One, you can describe the data, you can identify relationship, you can compare those variables, and then of course you can identify the differences between such variables. Take for instance, in a class 400 level, let's say, mostly some of you are 300, most of you are 400 or about to round up or to start carrying out your research as a final responsibility in your studies. That class is made up of, take for instance, male and female. Is there any difference between the two in terms of performance? Have you noticed any? If you're not too observant, you will never know that there is a difference between the male gender and the female gender in terms of their performance. And when we talk about performance, we're talking about their school, performance in any of the courses, any of the courses you can think of. So we can end up using that so that we can perform our data analysis. I'm trying to get my screen back. Okay, so I don't know if you are with me. Can you see my screen projected still?
Yes, sir.
Okay, okay. Um, so I don't know, the screen is covered. Jerry?
Try to use your escape button.
Okay, okay, okay.
Have you been able to locate it?
No, not yet.
Okay. Try double tapping on your screen.
Okay.
Still not coming up.
Okay, yeah, but I don't know. Is it shared?
You can go
Yeah,
out and come back.
you can see your
Okay, okay. Okay, let me stop sharing and share again. Okay, I think that's it. You can see, right?
Yes, sir.
Okay, okay. So when we talk about this analysis, we can do a lot of things when we talk what analysis does to that data. Remember, we say it can describe, identify relationship, compare variables, identify the different variables between the difference between those variables. And those variables might be in terms of gender, just as we have said, and then performance. Is there difference between the gender in terms of their performance? We can use other variables and triangulate among all of them. Of course, after getting it, we use analysis to forecast because that helps us to know what to plan, particularly those into budgeting. They don't just budget from nowhere. They use the past information before you can plan the next move. The key terms that will be useful in this analysis, when we talk about analysis, we need to still remind ourselves about population and sample, hypothesis. I think these are not new words to us. Hypothesis, data and scales of measurements, statistics. You will notice I dropped something making the S in red. Take note of that. But there's another word called statistic. And after that, we have analysis. Now, having seen this, I just want to take us back small so that we can connect with what we have today. What then is data analysis? Most of the times we confuse these words with statistics itself. When they say data analysis, our mind goes straight to statistics. Of course, you are not out of place. Some textbooks, they will tell you statistics and then you will describe analysis. Data analysis is occasionally referred to as statistics, whereas it is a component of statistics. Take note of the S. When we say statistics in general, it has a whole lot of description of everything mathematical and what have you. All these are referred to as statistics. Then, what then is statistics? You see, statistics in layman terms, we look at it from practical point of view. Because once they say statistics, it's somehow like a practical term. It involves, we take it back from data collection, and after you have collected the data from the field, you need to come and organize it according to those variables. And when you're organizing them according to each variables that you have collected. Take, for instance, gender. All the male, you collect their performance. Female, you collect their performance. It might interest you to know that some of them they are coming from different states. We can decide to organize it according to their states. And that means we have already started the steps in statistics. From data collection, you organize. But after organizing, you present. I believe from the last lectures, you must have seen all these steps have been taken. When you go to presentation, what we mean by presentation is you need to present that data in simpler form for somebody to get real meaning, as in fast meaning from what you have. And what do we use? Most times you see we use tables, we use pictures. And pictures like pictogram, we classify them under pictures. Like that, we say diagrams, some will say. When we say diagrams, we use pictures. Those pictures are, just as I've said, pictogram. Pictograms are using pictures to represent numbers or to pass a message very quick. We also have tables, we have graphs. By that, each one that suits your presentation, it depends on the audience you are giving them. Take, for instance, in the marketplace, those billboards you see, they are good forms of presentation that gets meaning, gives meaning to even that person who did not even know anything about the four corners of the class. That means all that you are doing, you are trying to make it easier for interpretation. But after that, you take it a step further. We call that summarization. What do we mean by summary? Summary is based on the data you have collected. Among the females or among the male, what is their total performance? And based on their performance, what is their mean performance? You can take it further. By that, you know you are going to come out with a single-digit number, single-digit answer. As, take for instance, mean, median, mode. These are single representation of the entire data you have collected. Once somebody will now ask you, what's the mean age of your class? You're going to give them a single number, as if it belongs to one person. But that's the central point. By doing that, you have given that information in summary. Without data collection, organization, and presentation, you can hardly get to summary. So these steps follow each other as they are arranged. But lastly, after summarizing, it will interest you to know one other component we mentioned was for analysis, was for you to achieve what we call forecast. How can you forecast about the general population? You remember at the point you carry out this research, you were unable to achieve the entire population and collect the data. But now, at the end of your research, you will find yourself talking about the entire population. For the entire population of nursing students, this is their average performance. Were all the members involved at the time of data collection? No. What you just used was just a sample. So for you to be able to summarize, for you to be able to forecast rather about the entire population, you use what we call analysis. This will now help you to understand where I explain that analysis is actually a component of statistics. In summary, what then is statistics? Statistics, simply put, it is COPSA. Can you see the screen? The COPSA. Just simply put, if you want to get what statistics is from data collection, organization, presentation, summary, and analysis. That means analysis is just a component of statistics. But whereas we have always been interchanging the word analysis to mean statistics. If that is clear, I want us to look at the population sample and sampling technique, which has already been explained sometimes by my colleagues in the past, just as a process. But I'm doing this to connect and so you can appreciate what we are doing today. The sample is actually the population you can meet. But of course, it's just a portion of the entire population. But you cannot just leave it that way. Sample is not just any portion. It is the a good representation of the population. Jerry, please, if there is any signal you need to tell me, particularly to time, I would just make a signal, sir. But I'm going. Just note that, because time will never permit us to finish it. We are just trying to summarize all to get ourselves acquainted with some of the terminologies. Most of the things you will do it yourself. But then, population sample and sampling technique. We must understand that what we mean by sample is a good representation of the entire population. So you can't just go and say you are carrying out research among your class members, but you ended up picking just your friends to answer your questionnaire. Of course, it might be almost half of the class, But if you look at it, it is not a good representation. No wonder they now brought the term sampling so that you can arrive at your sample. And sampling has different methods, which in this case, we prefer you to go the probability way. What we mean by that is every member of that class or member of the population had equal opportunity of being selected. That is, equal chances of being selected. You do that by blindfolding. You do all those balloting, all those random selection, systematic, stratified, all the sampling, that is probability sampling that were mentioned. By the time you do that and you collect your data from this sample that was selected using appropriate sampling technique, you now have what we call the sample. It's not just anything you use in your research we call sample. Sample might be biased. And once it's biased, it's not a sample because it's not a good representation of the population. What then is the population? Population is that group that you are talking about. The researcher is actually interested in it. But if you look at it, population is dynamic. It's not static. You're not saying you are working among HIV positive people in your local government and you expect to get all of them to participate in your research. Deaths can occur, movements can occur, new ones are coming in, and you understand that the population becomes so dynamic, but you know that these are people you are interested in. The highest you can do is just to get a sample. That is a good representation of the population. In true sense, you cannot cover population in any research. The highest you can do is to pick the sample. How do you arrive at the sample? Is by sampling technique. Back to data analysis. That kind of data you have collected, you remember that the data can, at earlier point, we say data can be quantitative or qualitative. If it is qualitative, fine, it falls into two categories. One, nominal. We use the nominal scale to get the qualitative. We can also use ordinal scale to get qualitative. What do you mean by nominal? What do you mean by ordinal? And of course, sometimes we use numerics. Numerics are mostly the quantitative data that fall into the numeric. Take, for instance, you are taking body weight of individuals. What does that mean? You are measuring them in numbers, and that does not change. We are going to see the differences, why we categorize them, and why we are using those different skills in the next slides. This is how we categorize our data. The data can be categorized into two, as discrete or continuous. Take, for instance, we are using numbers all through. We know sometimes we can also use numbers to represent quali. Quali in the sense that who came first in your class. That does not really mean quantity. It is just a qualitative description of performance. So in that instance, it is a qualitative study, a qualitative data. We have under qualitative, they are discrete. And discrete data can be nominal or ordinal. Nominal, take for instance, what is your name? Or can we collect your blood group? We all fall into different blood groups. Is there any blood group that is greater than another? Is there anyone that has a magnitude? No, that is one characteristic of nominal scale. Nominal scale does not measure magnitude of whatever you have. So we just give, just as the word says nominal, we give names, or we just give them for description. Take, for instance, your state is nominal. If I ask you your state, all of you are going to give me different states. Your preference, your skin color, all these are nominal. None is greater than another. So in that category, we have the sex, we have blood group as an example. When we come to ordinal, it's taking a form of number, but these are orders. Orders is, as I said, who came first in your class? Who came second? Go to another class. The first person in that class is not performing exactly the same as the first person in another class. So we are talking about order here. And in that order, if people are running a race, who came first? The first person might have covered in 2 seconds. Another might have covered that journey in 7 seconds. All of them are first in their own category. You can see that first here cannot be first in another place. nominal, ordinal scales are not reliable. But you look at it, the ordinal, they are just talking about ordinal and nominal, both of them are mostly qualitative. On the other arm of data is continuous data. And you look at it, we say there are two other forms of scale, which are interval and ratio scale. The interval scale, when you are measuring, take for the cardinal difference between interval scale and ratio scale is that interval scale does not have a zero value. Take for instance, can you tell us your body temperature? Is there any body temperature that when you say zero, that means there is no body temperature? No. Zero also means temperature. So for that reason, zero also means 32 degrees Fahrenheit for your own information. So that means there is no media that does not have body temperature. Can we compare this to our body weight or height? When I say zero, it means zero. That height is not there. When I say zero in terms of weight, it means zero. So that means there is an absolute start point and there is a zero point on the scale. That kind of data is called ratio scale. And then the one that does not have a zero starting point is called interval scale. Note these differences because this is going to explain what analysis, in terms of analysis, it will determine the choice of analytical measure for you to use anytime you have your data. What type of data have you collected? It also determines the type of analysis. So it becomes so important for us to talk about those things before we go into description of what data analysis is. Remember, we said statistics, and analysis is just an arm of statistics. But if you choose to still describe statistics as analysis, at the end of this research, this presentation, just note that statistics is divided into two major types. One, descriptive statistics, and two, inferential statistics. Mr. Jerry, am I audible? Are we following?
Yes, sir. You are audible.
Okay. Thank you. So we can now have a descriptive statistics and inferential statistics. When you know that statistics is divided into two, in this form, you see we have the descriptive statistics is just for you to describe what you have. You remember after data collection, as you have been taught last time, after collecting the data, using whatever means, questionnaire, focus group discussion, whatever means you use in getting the data, you have organized, you have collected, you have organized, you have presented. Now we want you to describe what you have. In written form, some can go by giving, you remember the summary now. The summary component of statistics now form what we call descriptive statistics. Because whatever you have there, they are going to give you single digits and they are talking about the data you have. Descriptive statistics is further divided into two types: measures of central tendency and measure of dispersion. What do you mean by this? Measure of central tendency is how closely to the center they are. And in that group, we have the mean, the median, and the mode. All these three descriptions gives us how central this data you have are. In terms of their distribution, we say, when you are given, if somebody asks you, what is the mean of your age, the age distribution in your class? You can quickly tell them that the mean is 32. It's a single number you're given. By that, you have summarized the entire work into single sheets, single digit. And in that, you mean you have already given all the information, you have summarized them into one. Where, close to the center, you are giving the middle information. Some can be higher, some can be less, but the central point is the mean. We can also describe some data in form of their median. When you arrange them in ascending or descending order, which one appears at the center? This is different from the mean. And in that case, we call that kind of data, that kind of response or summary, median. And of course, the mode is the one, the data that has the highest frequency. How many of you in that class are 25 years of age, 22 years of age, 23 years of age? We use frequency to describe what the mode is. and you discover that in a class, a lot of people will fall within a particular age bracket. That age bracket becomes the mode of that class. Measures of dispersion, which is the second arm of descriptive statistics. This talks about, just from the word dispersion, is how far they are from each other, how dispersed they are from the center. And of course, in that category, we use what we call the range, the variance, and standard deviation. The range means the difference between the farthest, that's the two extreme, the least and the highest in the class. But when we talk about variance, preferably let's talk about standard deviation. They are derivative of the mean, median, and mode, particularly the mean. You cannot calculate the standard deviation without you calculating the mean. So this is how they are related. On this same table, you will see that inferential statistics is one arm of statistics. It's one arm of analysis, of course, if you want to call it in loose term. But in this class, I would prefer us to call it statistics. So inferential statistics is one arm of statistics, and in that case, it's divided into two. The type of data you have will tell which type of inferential statistics you use. Take, for instance, you have collected their age distribution, but in this age, most of them are distributed, you see they are sparse. Most of the people in your class, if you check their age bracket, they are mostly within the center. When you have that kind of distribution, yes, it informs whether you use the parametric or the non-parametric. Parametric have different types of tools. One, the t-test. Two, the analysis of variance, also referred to as ANOVA. And three, analysis of covariance. We have different types of parametric tests, but for this class, I'm presenting just three. What happens if you cannot use the parametric test? You take an alternative non-parametric test. So for each parametric test you see there, they have a reflection, an alternative that you can use for non-parametric. What inform you to use parametric? There are actually conditions that inform you to whether use the parametric or the non-parametric. But for this class, just know that these are the division. Let's move on. Descriptive statistics. In descriptive statistics, the methods comprise of two major groupings, which we have mentioned, the measure of central tendency and measure of dispersion. The measure of central tendency, which involves the mean, median, and mode. Since I've described this, I will not want us to take much time. We have done this mostly in our preliminaries. Even in our early stats, that's 100 level, you must have done this in statistics. But just for mention's sake, they all fall into measures of central tendency. And we mean, with central tendency involve the mean, the median, and the mode. That means you are giving a summary of the data you have. Next is measures of dispersion, which I've described. We have the range, the variance, and the standard deviation. I will not want us to bother you. I will not want to bother you with their equations, but there are formulas that you apply smoothly to get this. Of course, when you are doing range, you should know that you are measuring measures of dispersion, how far they are. Variance also talks about how far they are from each other. Standard deviation also. But of course, measures of central tendency is still stand mean, median, and the mode. For example, find the mean, the median, and the mode of this group. Can this class try something? I know we don't have much time, but from our description, we have 5 information there. Just let's use 30 seconds. Let me know if my audience are following. Can you calculate the mean, the median, and the mode? The mean, the median, and the mode. Okay. Elizabeth, earlier you were experiencing bad network. Okay, I was expecting, okay, that's good. Olalekan Victor. Sorry for the pronunciation. Min is 6. Min is 6. Comfort Imo. Oh, Taiwo, you said the median is 5. And of course, Olalekan also calculated the mode as 4. Okay, so for the few response and for the sake of time, the mean, of course, is 6. Those who got 6 were right. The median is 5. And those who got that, thank you to know that you are following. And the mode is 4. You might have known this, but we need to re-emphasize. Because when you have data, how you handle it really matters. It is from this single piece of information that you take a further step into what we are talking today, analysis, mostly the inferential statistics. Now, when we go to dispersion, what is the range of this group? This same data, we can carry out measures of dispersion. And in measure of dispersion, can you give us the range of this group? Just let me know they are following. Okay, range. Favor, that's good. John Adioti. Chika Jones. Thank you for that. So with a few response, you see that the range is 6. But the standard deviation, I just put a formula close there. You understand that you must get the mean before you arrive at standard deviation. And by that, from the formula you see, the standard deviation is S, represented as S. In this context, you might see it different in different texts. But then, standard deviation means the summation of how deviated the mean is from each item. The xi there means every data you have collected. 4, 4, 5, 7, and 10. All of them are individual data. But how are they different from the mean? So you take their differences with the mean that we earlier found, which was it 6? The mean was 6. So how is 6 different from 4? What's the difference with 4, with 5, with 7, and with 10? And of course, after doing that, you divide it by the total population, that's the total frequency. And of course, you see that we have up to how many people? How many data? If these were people, and let's say this is their age, you see that we have 5 people there. But you remember that the mean also is a representative of an individual. So how are the others far away from the central individual? It makes the reason why you say n minus 1. N minus 1 means we are looking at how far they are from each other. And then, of course, from the central point, which is the mean. And once you have taken mean as a reference point, you have 4 other representing data to talk about. Of course, when you have done that, using the formula we have projected, you see that, I don't know if anybody has been able to calculate that, but that time may not permit us. Standard deviation is 2.55. If you have time, you can do that. But then the variance is a square, taking the square of the standard deviation. So by that, it takes you back and gives you the value that you got before arriving at standard deviation. The answer becomes 6.5. It has other fractions. Having seen this, we have taken example of seeing measures of central tendency and measure of dispersion. All fall in the arm of descriptive statistics. Now, we have the next is, my screen is frozen. Okay, it's freezing. Okay, having seen this, I need you to understand that data you have collected. You remember about our data presentation. We can present this data in forms of graphs or in forms of charts. We can have the bar charts. But when you present, earlier on I was telling you something. If we plot your ages, you see most of your ages will fall within the center. Most of you will fall within an age bracket. Only few of you will be too old for that class, and only few of you will be too young for that class. Having seen that, each time you plot a graph and it shows you this, And by eye rolling, it gives you this shape. We call it a normal distribution. That means we can describe the type of data you have. I'm saying this so that it will usher us into our inferential statistics. In this, when you plot any graph like this, you can. Today we are talking about analysis, and of course, our CEO, we are organizing. When we were talking with her, she said there are a lot of tools that are doing. Yes, but the argument here is you must know the basis. Why must you use an inferential statistics of this type? Now, when you have a set of data, it gives you this shape. We call it a normal distribution. The first one that has that graph with all the bar charts plotted, you will see this shape is referred to as normal distribution. But in case you collect your data and most in your class are young, take for instance the table A, the A figure A there, you're going to see most of the students are younger and only a few of them are old. It now skew the distribution into the positive side. And in that case, if you have this kind of distribution, we call it positively skewed distribution. If you plot the graph again, and it gives you that most of them are of the old age and only few of them are at the younger age. I'm using age to take, for instance, our distribution of our data. So every data you collect, you must find out how the distribution is. Is it normal distribution? Is it skewed? And if it is skewed, is it positively or negatively skewed? So every data you collect, particularly quantitative data of continuous form, and what we mean by continuous form, it does interval scale or ratio scale. If you plot these graphs and they give you this kind of shape, please, this is a skewed distribution, the A and the B. But aside that, we can have the normal distribution. Why are we talking about this? The normal distribution is required for us to know what inferential statistics to do. Did you remember the types of inferential statistics we mentioned earlier? Oh, that's good. Ibrahim and Anasel, she also, is it a he? Well done, you calculated standard deviation earlier before we posted that. I didn't take note. But now we are on inferential statistics. What informs you to use the parametric or the non-parametric? Remember that I said in every parametric test, if it does not fit, go to the non-parametric. Now, what informs us is the inferential statistics, of course, is actually a measure of population. I remember when we are talking about parametric tests, when we are talking about the use of analysis, we say that it helps us to forecast about the population. So you see what inferential statistics does? This statistics enables for you to draw inference or conclusion about the general population. But what you had earlier was a sample. It is based on laws of probability. No wonder we had to introduce the distribution so that we can talk about binomial distribution, which is a basis of probability in every statistics, in every discussion you want to make. These statistics, the inferential statistics consist mainly of estimating parameters and testing of hypotheses. Along the line, before we got to this date, when we were taking, after your literature review, most of the time based on what you have, you're able to come up with a topic. But from your topic, you as a researcher, sometimes you make some level of suspicion. You are just guessing that this might likely be this, but because I've not subjected it to test, I will leave it as a guess. That guess is referred to as hypothesis. So now we use inferential statistics to test that hypothesis you have mentioned earlier. And in this case, you know the outcome is going to be either you accept what you said earlier or you are going to reject what you said earlier. Inferential statistics help you to make this decision. In inferential statistics, we have made mention of hypothesis. And this hypothesis might be mentioned in two different forms, because you, the researcher, you want to find out, after collecting my data, what becomes of the data. I wanted to answer a hypothesis or one intelligent guess, or to clear one doubt I have. And that doubt, you mention it in form of a statement. That statement says there is either relationship or there is difference. Remember, like in that your class, where we said, is there any difference between the male and the female? You will not know. The highest you can do is to guess, and that guess is referred to as hypothesis. But the aim of research, if you follow all the steps, is for you to come and answer or clarify that guess, so that you now make it an authoritative statement after the research. In that instance, you are going to accept that which you have proposed earlier, or you are going to reject what you proposed earlier. That proposition is referred to as hypothesis. And hypotheses are mentioned in two forms. One is the null hypothesis, which always says that there is no relationship, or there is no difference, or that which you are suspecting, you say is not there. The alternative is for you to mention that that relationship is there, or that difference is there, or that which you are suspecting is there. So two statements are always available, so that at the end of the day, you have an option to go with one and reject the other. We also talk about level of significance. Is it at all stages that you accept your statement to say it is true? When we are talking about probability, probability is just a matter of chances. And your chances, we can only agree with what you are saying when you are approaching 100%. So will you accept that your statement, even when the truth level is just 20%? So the level of significance is always mentioned in every inferential statistics, so that you use that significant level and say that this is my yardstick. If it crosses this, I will not accept my statement. But if it crosses the other part, I will accept. Or if it has maintained this high probability, I will accept whatever proposition I'm saying. So before you start that research, you mention your hypothesis. It's good for you to mention your level of significance. Is at what level? Let me bring this down home. Do you remember when you were admitted? Some of you came in through JAM. And in your school, your JAM score will differ, their JAM cutoff point will differ from another school. When you go to another university, their cutoff point might be 240. You can't come into nursing. While some will take it to as low as 180. That means it's at the discretion of the researcher to say that this is my yardstick. Whoever, if my findings at the end of the day is giving me high chances that there is low error and the error is just this percentage, I will accept it. But if the error is too high, I will not accept it. So at that stage, as a researcher, you mention your level of significance, and that is just like similar way as the yardstick. Everybody has his own. But in health, we prefer to use 5%. That's why you always see them mentioning a 0.05 significant level. I want to know if we are following.
Yes,
Hello?
you are following.
Okay. 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 But are you really understanding? Okay.
Yes,
Thank
sir.
you, Esther. Thank you, John Adeti.
Yes, sir.
Thank you for that response. I just want to know we are on track. But most times you hear them mentioning significant level. Significant level is just at the discretion of the researcher. But in health, because we are dealing with human life, if they tell you that this drug can heal only 50% of the population, should we use that drug? And then if they also ask you that this other drug can heal 95% of the population, if they are to treat 100 people and 95% will get cured from this drug, which of the drugs will you go with? And which one will you want to apply in human beings? Because the other one is just, we don't want to play with human lives. Likewise, the decision you're going to make about your hypothesis. If it is not high, if my chances, the truth chances are not high, then I will not accept it. In other words, if the error you are making in that decision is as high as more than 5%, then that means please don't subject human beings to that kind of your findings. You cannot conclude. So for that instance, most of the times they reject or they accept the hypothesis, depending how it is mentioned. But it's good for you to mention your significant level, which inform you about the decision for you to make at the end of this research. The level of significance attach a probability error to the rejection of the null hypothesis. So if I have anything, if the error margin is more than 5, I will not accept whatever I'm saying. That work, if it is drug I'm giving, I will not want to use that drug on human beings. That's why the significant level is also written as alpha. You can see sometimes they use 0.05, but you understand when you transmit this, it is the same thing as 5% error. Many people have given it different names, from significance level, alpha level, error, then confidence interval. All these are used interchangeably. They can tell you at 95% confidence interval is also the same thing as telling you that 5% of the remaining, the researcher is not confident at that stage. That means the 5% is the error that he can make from that research. Having seen what hypothesis is, you are bound to make some errors. As a researcher, you need to watch out for this. Hello, students. Sometimes I need to pose at this level. But the truth is, that data you are collecting, if you make error in your sampling, if you collect even when you have done good sampling, but the number is not adequate, you're surely going to make an error in the decision. And that decision is what researchers are avoiding. This decision, you can make correct decision. Likewise, you can make an error in your decision. If you are following, and take for instance, you are a nurse in the hospital. A patient came to you. You are seeing obviously a pregnant woman. She entered your office. You check her for pregnancy. After testing this woman, she is telling you all the signs are there, but your test strip is telling you that this woman is not pregnant. Will you accept that test? Class, I want to know whether you're following. If a woman is pregnant and you, after carrying out a test, and the test is telling you that this woman is not pregnant, will you accept that test? Okay, but I just need to know whether they are following. And of course, when you are doing that, you remember you're already making a fundamental mistake. A mistake of having a negative result. That means it is false negative. When you have a false negative result, it is referred to as type 2. Thank you. I've seen Precious, I've seen Samuel, we need to check for possibility of error. Good. So that's why I'm just listening. I'm looking at their response. So it's good to know you are following. So let's take another instance again. A man walk into your office and you say, you don't understand what this man is saying. No, can I check him? You carry out pregnancy test strip, collect his urine, and you tested it. Your test strip is now telling you that this man is pregnant. Will you accept such results? You know this is a man. Biologically speaking, we know he cannot conceive. And then yet, after the test, you discover that this person is pregnant based on your test result. In that instance, you know for sure that your test is error, right? That error you have made is referred to as false positive. Yes, Samuel is more like, we can laugh about it. But a pregnant man, from your hospital, you diagnose a man pregnant. So that means everybody will know that you have made an error. That kind of error is referred to as false positive. False positive are referred to as type 1 error. False negative are referred to as type 2 error. Even if we don't achieve anything and you get this, it's a good foundation for you, because this informs the final outcome of analysis. At the end of your analysis, whatever you come out with, it's for you to answer this. Let's come back. The inferential statistics have parametric and non-parametric. And the first one we say it is when we call it parametric. You remember the graph? The first instance, the first condition for you to use parametric test is, permit me to take you back to some slides. It's only when your slide with your description or your distribution is normally distributed. And by that, you know what normal is. When even all your other conditions have been collected, have been satisfied, but you check the distribution of the data, once it is skewed, you cannot use parametric. So one of the fundamental conditions of using parametric test is when it's normally distributed. From the screen, you can know, you see what we mean by normal distribution, right? So what is normal distribution then? Normal distribution is when you have put all the data, plot them against each other, against the frequency and the variable you are looking at. You will see that majority of them are always at the middle. And if they are at the middle, that means for a perfect normal distribution, listen, 3 conditions must be satisfied. One is that the mean, median, and the mode are at the center. That time you calculated mean, median, and mode. If it were normal distribution and the mean that you got to be 6, you will see that the mode will also be 6, the median will also be 6. When you have this kind of distribution, look at it well. It's actually normal distribution. 2 is that the shape, that's the dome shape, the bell shape you see of normal distribution, it's at the center is symmetric. That means the half side is equal as the left side. So it's a mirror of the other side when you divide this into 2. And 3, do you see the extreme? The tail end. The tail end will never meet the x-axis. So when you plot this graph, they will always come close to each other. And by theory, these 2 tails are believed to meet at infinity. If these conditions are met, then handling parametric tests. Let's understand what parametric tests. These tests are known as normal distribution statistic tests. They make certain assumptions about the population from which the sample is drawn. The reason why we are running this is for you to generalize about the population. What you have is sample. We will go into parametric, that's inferential statistics, so that we can have idea about the entire population. Will you say the mean is 6, therefore the population mean is 6? No. So we need to subject it to statistics, and that type of statistics is called inferential statistics. So for us to subject it properly, to know about the entire population, we either use parametric or the non-parametric. Now the parametric, we are saying that the condition is that it must be normally distributed. The assumptions are that the populations are normal distribution. If it is not normally distributed, you cannot use parametric test. Surely you are going to make an error in your last findings. That means you are going to make either type 1 or type 2 error. Parametric tests have 3 attributes. 1, they focus on the population. 2, they involve certain assumptions about the variables that is being analyzed. And 3, they require at least an interval scale. So the measures must be interval, it must be assumption about certain variables, and it focus on the population, not the sample this time around. But of course, you use what is in the sample to make that generalization. If I ask you, why do we carry research? We carry out research for us to know what is it in the entire population, but we cannot get the entire population in our research. So most times we take our research from description from descriptive statistics further to inferential, so that we can generalize about the entire population. So descriptive statistics gives us about the sample. We have the parameters there. We have the statistic. Sorry, I did not explain what statistic is without the S. Those mean, median, mode, standard deviation, variance, whatever you have, that single value is referred to as statistic. So when you have the statistic, you now take a further step so that you can do the inferential statistics. When you go into inferential, is for you to generalize about the population. So it's important we understand this, because at undergraduate, most of us will now come and say the mean of our distribution is this. standard deviation is this, range is this, and you stop at that, actually it will not benefit the entire population. The reason for inferential statistics is for you to forecast on the general population. Haven't seen the conditions of parametric tests. The non-parametric test, on the other side, does not need to fit all these conditions. Once you cannot get a good fit in parametric test, once the condition is not met, please, there is another tool that you can use, which is the non-parametric. They are listed there. The non-parametric statistics uses data that is often ordinal in nature, meaning it does not really rely on numbers, but rather on ranks and orders. You can see, that means to tell you that when you have collected your data, it doesn't necessarily mean it must be interval scale or ratio scale. Even when you have nominal, that you have the frequency, you can use non-parametric tests. What are these parametric and non-parametric? Parametric tests, the examples are on your left side, depends on how the screen is projected. The parametric tests involve the independent t-test. Earlier on, we mentioned something as t-test. The t-test, the ANOVA, the ANOVA, the ANCOVA, the MANOVA, we have a lot that our screen cannot take. While the non-parametric, we have the Mann-Whitney-U, Wilcoxon match, Pierce sign text. We have Kruskal-Wallis test, and then Friedman's ANOVA. These are alternative. If you cannot use this tool, if this tool, the conditions are not met, please go to non-parametric test. If the conditions in parametric, you intend to use t-test, but when you check, when you plot it, your data is not enough, it does not meet up the conditions of normalcy. Of course, switch to the non-parametric. Haven't seen this. The tools, anyway, you understand that knowing the basis really matters. And in the basis, my battery is shutting down. In the basis, sorry about that. In the basis, we have different types of parametric tests, and we have different types of non-parametric tests. These two are referred to as inferential statistics. Number one there is referred to as, you remember earlier we said t-tests, but these t-tests are in two types. One, we call it the independent t-test. The second type of t-test is referred to as paired t-test. So, the independent is also referred to as different sample t-test, because they are independent of each other. The paired t-test is also referred to as same sample t-test. Rather, we can also call it dependent sample t-test. I just want to know that this class is paying attention now.
Yes, sir. Sir,
Okay, thank you.
I don't know if we can hasten up because of time, so we can get to the practical section.
Okay.
Yes, sir.
I'm conscious of that.
Thank you, sir.
So, okay, thank you. So just let me clarify this, because when we say t-test is mostly used, and you see one other inferential statistics is the chi-square. So the t-test, they are in two forms. Let me give this example. If you have a class, you remember when we started this program. At the end of this program, we want to know whether there was an impact of this 8 weeks program we have done. So what do we do? What kind of design will you take? It's actually somehow like an experimental test, right? So those people who started, we started, yes, and you know that it's the same people that will end this program. How will you know whether this has made an impact? For that reason, it's the same group of people, you test them twice. At the beginning of this test, at the beginning of this program, we will test your knowledge in research. I believe you have filled that form. And at the end of this program, we are also going to test your knowledge so that we can assess if there was an impact. For that reason, you will understand that it's the same set of people, but they are having two results. When you are having two results, you are going to use, because we are trying to find the difference between the beginning and the end. That kind of test that are preferably for you to use is called the paired t-test. It's a paired t-test. It's the same sample. The same people are giving us two results. But now there are type of designs in research that you divide them into two: the control group and the experiment group. The control group, when you give them same test, and you give the other group same test. That means two different groups of people are giving you two results. In that case, you are going to use the independent t-test. You use the independent t-test. So the t-test is actually to check, is a test of difference. Is there any difference between this group and that group? Or is there any difference between when you started and when you end? So it depends on how you design. So somebody will look at your work and will tell you that you're not using the appropriate data tool or analysis. When you have that, is t-test. But when it's not normally distributed, you use the alternative as I've mentioned. Chi-square tests relationship. Is there a relationship that exists between your age and your performance? In that instance, we use the non-parametric chi-square. What are the tools? The tools we need in data analysis. Today, in the world of AI, we may not need to stress yourself with all this, but our emphasis is just know the basis. Even when you don't carry out your analysis, you should be able to direct the statistician on what to do. After all, am I a statistician? That means the knowledge is not meant for one person. You can go and learn and also run statistics, run inferences, run descriptive. So you need to have these skills. And when you are carrying out your work, you should be able to direct them on what you actually want. The mistakes we are making is, even with the AI, you give in and you make mistakes in your input. You will not be able to dictate when it's giving you a wrong output. Likewise, when you give a statistician, it's just garbage in, garbage out. We need to depend on his knowledge. For that instance, whatever he gives you becomes your results. So, what are those tools we have today? We have the spreadsheet. The spreadsheet, that's Microsoft Excel for quantitative data. We can run all this descriptive, inferential. We can also run the descriptive and inferential. And in the descriptive, we can carry out this measure of central tendency and measure of dispersion. All the spreadsheet can do that for you. We need to know the skills. That will take us into the next class. But of course, next session of this presentation, we're not going to take much time. We just have the same example. We just put it and run it, and that's all. But just know that these are several tools. You remember when Sample was saying it? He said that you should go into R. He's going to different tools that he mentioned. Go and equip yourself. For the mere fact that you are a nurse does not restrict you to just the bedside. No statistics, because you are in for research. When you don't carry it, you give to somebody, and he gives you results. You should be able to challenge that result or criticize that result to know when it's good and when it's wrong. If not, you are going to make the mistakes that researchers are avoiding, type 1 and type 2 error. For qualitative, we have different softwares that can do that. The most common among them is called the NVivo. But it's always difficult when it comes to qualitative. At this stage of undergraduate, we focus on the quantitative and we get ourselves acquainted to this. Second section. In our second section of this presentation is just, we are going to take one example and we call it a day. Use of MS Excel spreadsheet for data analysis. Is that okay, Jerry? Okay.
Yes, sir.
I can see you know that already. So we are going to look at how can we do data presentation. Most of you must have, some have seen, but some have not. At the end of this presentation, this second session, is for us to know how we can maneuver using Excel. But beyond Excel, we have the SPSS. Most of you will just collect data as our students, the tradition, they will collect data and say that it was run on SPSS. Ask them how it was done. What is the formula involved? Nothing. They will just say, the statistician gave me this. Actually, we want you to own your work. You direct the statistician, not the statistician directing you. He can only give you advice. So for that instance, please pay attention. We can use Excel to do data presentation. And in our data presentation, you remember those graphs I mentioned? The pictures, you can do your pie charts, you can carry out bar charts, you can ask the Excel, program it also to plot different graphs for you, trends, and you see how that data is distributed. Also, you can also carry out the view of your data in terms of how is the distribution. Once it plots, it will have an idea. It will give you an idea that this data is normally distributed or not. We're also going to use the spreadsheet for the statistics like mean, median, and mode. And if time permits, I'll just demonstrate little of the student t-test. Good evening, class.
Good evening, sir.
Good evening. Just want to know you are following, and I hope if there are questions, you can also be putting them side by side. I'm paying attention to your comments. Okay, so at this point, I would advise, if you have your computer, put it on and open Excel, your Excel, Microsoft Excel Word. Use your Microsoft Excel. Open it if you have it. If you don't have, don't worry. We'll demonstrate the little we can. You remember the data you have? Some of you have their jotters close to them, and you were able to pick up the data we have. Elizabeth, it's just due to time constraint. We have a session.
Yes, sir.
Yes, it's due to time constraint. She's asking if we are going to teach SPSS. Honestly, it's very important, but even the whole day cannot take us. So we are using the spreadsheet for now. If at other time we have the opportunity, we use SPSS and we'll demonstrate the basis for you too. It's good that you ask such question. I'm sharing my screen again to pick the Excel. And when we say Microsoft Excel, so sorry about that, Elizabeth. ELO, right? So now that we know, the organizers will also take note of that. Assuming this is an Excel sheet, of course, this is an Excel sheet. And on your Excel spreadsheet, you will see I was trying to put up some data, some information. I need to know if you have it handy. Just raise your hands or just indicate, let me know if anybody is following. This is an Excel. On your computer, an Excel. Okay. Oluwaseun Adepoju. Precious. Temi Lola. It's good to know you are following. Elizabeth Akimbola. So I'm just taking a little moment to just see this. We don't have much time. I'm conscious of the time. But remember what we have. Can you key in this data? Initially, in our example 1 and 2, when we were doing descriptive statistics, we gave 4 or 5 numbers, and we assume that they are student age. I just call it data here, whatever you call it, but it's just for demonstration. This is just to enable us It's just to enable us to carry out measures of central tendency and possibly measure of dispersion. For those who have, I've seen a lot of yes, I've seen a lot of responses. For those who have computer, it's good for you to try this. Just key in these 5 numbers. That's why I don't want to give you much numbers for us to finish this on time. Even if it's just 2 numbers, use it. But whatever you have there, this spreadsheet you are seeing is embedded with a lot of formulas. Check my cursor where I am pointing at. You're going to see one f of x. It's an indication that there are embedded different options for you to carry from your statistics. You can run, it's embedded a lot of formulas, with a lot of formulas. And those formulas can carry descriptive statistics as well as inferential statistics for you. All what we need is your real understanding. Because if you cannot apply it, it means you are making a grave mistake. With this, if you have keyed in this information, how can we get the mean of this group? You remember it was 6 years, but how can you get it? Take, for instance, you have a lot of this information. We are carrying out measure of central tendency. And for this, I will just use that for mean. I have created a box called the mean, the standard deviation, and the variance. In your mean, we go to the box next and click that, please. Each time you are using Excel sheets, for this instance, we want to calculate mean. Before you activate the formula, if you don't activate it, whatever you are doing is just mere typing. Take, for instance, see what I'm doing is mere typing. How do I activate a cell for it to calculate? I come to where I want my answer to appear, just in front of the mean, see where my cursor is. I click it. I want my mean to appear here, and mean is one of the measures of central tendency. For us to activate it, you use the sign, equal sign on your keyboard. See what I've typed? Immediately you write equal sign. There are different ways you go about it, because the formula for mean, how do I get it to pop up? I will double click in the box after writing the equal sign. And the mean is represented as an average. Can we type average? Average. AV. You will see that there will be a drop down that will appear, suggesting to you different formulas that are there. The first one, because I just put AV, is AVDV. The second is average in full. So if you are following and you click on the average, double click on the average, and of course, it's going to give you a pop-up of query for you to input. Average of what? That's just the question. And the Excel sheet is designed in such a way that you can give command and describe the address of where you want your focus to be. In this instance, I want to take average of array of numbers. And the numbers start from cell number D6. I don't know how it appears on your own. But can you see D6? That data number 4 is on D6. If I write D6, you see that it's going to select that cell. And I'll put...
Mr. Bonji indicates that.
Yes.
Where the D is coming from, so that the...
Okay. So D is on your keyboard.
The column and the row.
Yes. So you see, I'm using my cursor now to point where D is. Because this is it, all the column, all that appears under this row is referred to as the D cells, right? All this I don't want to click it because it's going to destabilize all that we are doing. But let me just give it a trial because we can always undo what we have done. You see, I've selected all that appears under D. But on this site, you see that it's carrying numbers. And on your numbers, according to my Excel sheet here, this cell I'm particular about starts on row 6. So you see where I was making reference to D6, D6, D6. So let's come back to our formula proper. I'll start again. In this formula, I put my equal sign. And equal sign, remember the steps, I will spell average. But the moment I put AV, it brings suggestion. Actually, what I want is average. There are different types of average, but this full average is what we're using for this class. I double click the average. Now the next thing is telling me, where do I want to take the average? Average of what numbers? Arrays of numbers. So the first option I said is for you to type it. From your physical view, you know that 4 appears on cell D6. You remember how we arrive at the D6? This is the address D and number 6. That's where the point. So I can end up typing D6. Immediately I put D6, you see where it's highlighted. Once it's there, I put the colon. Type colon. I see what I'm doing. I just type in something. So from D6 to what that means is I'm taking D6 to the last number there is cell number D10. D10. Your own might have different address. Is there anybody that is following me to carry this?
Yes, sir.
Yes, thank you. Thank you. So you will see that sometimes you make errors, but of course you can undo it and try again. That's the beauty with all these apps. So on D6, I want to drag this down to D10 because these are the numbers in question. So I can equally type the next address is D10. I don't know how it appears on your own, but you can see immediately I do that, it highlights the whole of that group. I'm sorry, maybe I'm using them interchangeably, but the vertical. So you see, by putting D6, I have eliminated D5 because on cell D5 is not a number. So it is D6. Once you miss the address, you're going to see an error in your presentation. When you have this, it is good you close the bracket. Remember the initial bracket, you were not the one that opened it. Immediately I selected average, the bracket open. If you are following, we're expecting those who are just at elementary, but if you just know, even if you know, please follow us for practice sake. After doing this, can you press enter? Look at your keyboard and press the key enter. I will not press it at my end, but when you enter, what was your answer? Okay, that's good.
See.
Thank you, thank you. Have you seen that? That means, but when you go to the cell itself, see where my arrow is pointing? When you click the cell, it's not the number you will see at the address box. So that formula bar, you are going to see a lot of formulas written, but here what you are seeing as an output in front of the mean, it has given you the mean of this distribution. I hope you appreciate it. Just get this simple step and keep, because you are going to be dealing with large data. Now, standard deviation. I will do the same approach. Come to standard deviation cell. I want to activate it for formulas. You remember the step again? I'll put equal sign. And I'll put standard deviation is also start with ST. So even if you cannot get what the computer mean by standard deviation, start by ST. You will see a lot of standard deviation with different suggestions. Just stop it as ST. Please, is anybody following on this? Because we are calculating standard deviation of this distribution. Remember, you have the formula. Okay. Akimbola, you want to talk? Okay, yes, thank you. Pimiloye, Ayomide. So please pardon me if you know where I'm coming from. So when you have this, somebody is designing my screen. Please, I understand, but allow me to finish this first. So, okay, I hope that can be undone by your side, at your side. So when you have this standard deviation, which one are we going to select? There is standard deviation with P, there is standard deviation with S, there is another standard deviation but has VA. I want you to focus your attention on these two. These two, the P and the S. Yes, these are the correct, but which one are we using at this point? If you are listening, the purpose of this is for us to differentiate and know the appropriate tool to use. When you use this is matter of where do you get the data from. I remember at the beginning I said you can hardly get the data of the entire population. But yes, in some fields of science, they can have access to all the population of what they are dealing with. It might not necessarily be human beings. But when they are human beings, it's hard for you to get their population. Now, what you have collected was just sample. You remember? You see these are from sample. If it is sample, then we are calculating standard deviation of the sample. But if, assuming this data was collected from the entire population, you did not miss one of the data, one of the subjects, then of course you can go ahead and use the standard deviation with the P. But in this case, our right option is standard deviation of the sample. I have selected it, but I need to double click. If not, it will not appear. If I double click, like manner, you will see that it has opened a bracket with the command. When you see this, the next you need to do is to insert the description. And you remember our D6 to D10 is still the same description. Have you seen that I've selected the address? Of course, if you just press enter, the answer will come out too. Oh, now you see the detail of where the standard deviation came from. So I'm taking this step just to make sure you are there. I hope there are responses too. Let's go to the variance. Likewise, in the variance, we double click. Now we have got to standard deviation, but of course, this can be rounded up as 2.6. I don't know, but whatever you choose, if you do the manual calculation, you will need to be rounding up, but you end up having 2.5. But our variance, remember, it also has a formula. So our excess of this description, this presentation, is that you cannot just calculate mean without knowing the formula of mean. So the earlier part of our presentation was to tell you that this is the formula for mean, this is the formula for standard deviation and variance, and that's what is embedded in this Excel sheet. It performs several wonders, and of course, you can see what is happening. In the variance too, I can activate this and put equal sign and select VA, and you see variance for population and likewise variance for sample. So if we have variance for sample, we double click and we make our own description too. Description of what? Of the cells from D6 to D10. And you close the brackets. After closing bracket, you enter. You see what we calculated earlier? The variance is just the square of the standard deviation. If you try that manually, you're going to see it. Or take the square root of the variance, you're going to arrive at standard deviation. I hope this little demonstration makes little sense. Just pick the idea, just pick the step. There are a lot of formulas that myself, we cannot exhaust. We don't know all, but just know where they appear and how their uses are and how they can be applied. So the bad side is you selecting a formula and you don't know how comes the formula. Then, for instance, you select mean. You don't know how the calculator does the mean. So it was the excess for our first presentation. Having seen this, I think we can take 2 data, carry our presentation, and we move on. Let's present another set of data. Look at the sheets. On your Excel sheet. What you open there, you see Excel sheet 1, sheet 2. If you click the plus sign, it keeps adding the sheets for you. It's just like you have a book and it has different pages. So let's go to sheet 2. If you have opened, let me know. Okay. Have you opened sheet 2? Jerry, can you hear me?
Yes, sir.
Okay, Jerry is my test sample. Thank you. Thank you, Jerry, for making it easy for us. So I'm going to enter some data randomly. Take, for instance, months of the year, quarterly. Let's take 3 months. January, February, March. So we're talking about months, right? Months of the year. Assuming you are in the hospital and every month you are in the ANC unit, antenatal population, antenatal attendance. So we want to plot this distribution because we are just making head counts. Head counts of attendance. Which months, how are the people, their attendance throughout these 3 months? Let's say first month in your small clinic, you have 20 ANC, women that came for ANC. ANC, by ANC, I mean antenatal care. In February, you have maybe this number reach up to 29 or better still, 30. In the next month, I'm just giving random numbers, 50. We can take this to April. And let's say in April, they drop down to 15. I remember in our statistics definition, you remember the COPSA, right? The C, the O, the P, the S, and the A. So in this example, we are using the Excel sheet for our P, which is data presentation. Of course, we have used the table, and if this is the table, these are the headings. But we have collected the percentage, what do we call it, the attendance per month. I'm using this so that we can plot different graphs for presentation. Is it bar charts? Is it pie charts? What have you? When you have this, we say we use it to present our data. You remember when in our earlier presentation in our first sheet, we have covered both the measure of central tendency, likewise the measure of dispersion. In this instance, in this page, we are focusing on data presentation. And data presentation can come in different formats. Go to your Excel. I'm taking style to know that people have typed in. And if you have typed in, on your Excel sheet, if after putting in these numbers, you can see at the up ribbon, the ribbon on top of the Excel, there is a key called Insert. There's an option for Insert. Click on the Insert. And the Insert has different divisions. The ones that have tables. We have the place that have illustrations and pictures. Because I want to insert something on this spreadsheet we are having. We can also insert charts. And charts are of different forms. I wish I know that you people are seeing where the cursor is. Apart from charts, we also have what we call the spark lines, where we use them for trends. And we have a lot of functions on this Excel sheet. Ibrahim Anasel, are you really doing this or you are just following the screen? Okay. So, what do we want to insert? First of all, let's go with the bar chart. For us to insert anything, first of all, you must make reference to where you want the data you want to be plotted. I just highlighted. I clicked on from January down to April. January down to April. I shift my cursor down while holding it to highlight the numbers 20 to 15. These are their months and their attendance. So first step in this is for you to highlight. That is my reference. And then I will go up to my bar chart. On my bar chart, there are different categories. One, the simple bar chart. The second are line graphs. The third is the pie chart. So we have different choice to make. Different people have different means of presentation. But for this presentation, let's use the bar chart. And when immediately you click the bar chart, it gives you options of drop down. The drop downs are, we have the compound bar chart, we have the composite bar charts, simple bar charts, and of course, different types of bar charts that we have. The 3D, different designs you can choose. So as you shuffle around, you see what is happening. And of course, I would prefer, based on my choice, can we select the first one, simple bar chart for demonstration purpose. Immediately you click that, you see that your graph is plotted. Some of you will be wondering how it's done. Some have done it, some have learned on their own. But for those who are seeing it for the first time, I'm taking this gradual step for you to see. For a data presentation, you can present it, particularly when you have categorical data in form of frequency. In January, what is it? January, you see that 20 people attended. We can decide to give this graph a title. And this is where you see the right chart title. You can enter this manually too. You see the bar chart? The bar chart can come in different form. The simple bar chart, this is what we have. We have the composite bar chart. And is it the compound bar chart? Side by side, where two bars are representing one particular item. Having seen this, we can also go look at look at the data that we have from January to April with different outputs. You can also see, we can equally plot this on, I'm deleting this. So we can equally plot this on a pie chart. What do you mean by pie chart? Pie chart in its entire cycle is having 360 degrees. So can it distribute all of this into degrees for us, into angles? Okay, thank you. So having seen that, you can go ahead, Jerry, signal, right?
Okay, yes, sir. So the time, sir.
Okay. Yes. I'm rounding up with this.
Okay.
So for our pie,
Mr. Banji, they can all figure out the pie chart from the one we have done. Maybe you can show them if they need to use proportion, because I think, because that is what is relevant. Another thing that is highly relevant to what they are presenting.
Okay. So now let's go, because from what we have done, you have different options. You can also go for the pie chart. Maybe that will be our assignment. But how do you know when we talk about proportion, what proportion of this population? I'm just using this as an example. Let's add another title called proportion. What is the proportion of those in the attendance in January? In January, you have 20. February is 30, just as you see on the screen. How do we arrive? What is the proportion of those people in January? We are talking about the entire population. What is the total population? We can get that by going to the last cell, and let's also calculate the entire population. I would have asked you, but we can equally do that. Activating it, there is a formula where it can sum up these frequencies for you, so that you get the entire population. The entire population or attendance from January to February, you put your equal sign and you type sum, SUM. SUM is the first thing there. Double click it and add up from where? From January to April. So I will not go the normal way of in this case is E7 to E10. Am I right? E7 to E10. When you do that, put your enter and it has sum up. This because we selected them randomly and we have gotten the total. Haven't seen this total. The proportion here, for proportion of January, you equally press the equal sign because I want it to be calculated on Excel. You select the cell. You see, after selecting the cell, you divide by the entire population, which is this. But in this case, I will not select this cell. I will just write the number since it is a constant, 115. But you understand, proportion in what sense? Is it in percentage or in terms of the angle? If we are talking about the angle when we want to present it in terms of pie chart, we multiply it by 360. But in terms of percentage, we can multiply this by by 100. Our multiplication sign is key number 8. You see a star sign there, and we multiply it by 100. Press your enter key, and you see what you have there. And you just hope that my students are following. What you have there is 17.3.
Yes, sir.
Yeah, thank you very much. Thank you. So 17.37. So this is the proportion in terms of percentage. What's the percentage of January in the entire attendance from first quarter? First quarter means first 3 months, right? Or is it first 3 months? First 4 months. So when you have this, you understand that for 20 out of 15, it is 17%. For 30, what is the percent? We don't need to type the formula again individually. just come here. See how, let me expand the screen. Now, when you are here, see where my cursor is. As I drag it to the last end of the cell, it changed from this box cross down to a cross. At that point, you click and drag down. Click, hold, and drag down. I'm using a mouse. What it means is I am applying that formula to all the cells. Once you get to where you want, release it and see. All the percentages appear. But you see that what you are seeing on the screen, it has up to 4, up to 6, 7, or 8 decimal points. As it is, I can reduce this because in your presentation, we cannot be accepting this kind of numbers. We can reduce it. I know you want to say you are doing it manually, but there's a place for you, an option for you to reduce the digital points to whatever number you want. To here, you see where my cursor is where you decrease the decimal points. How will I decrease the decimal point? From 8 decimal points, I can keep clicking. I hope what I'm seeing is what you are seeing too. Clicking, and I leave it at 1 decimal point. In that case, you don't need to do any roundup. Add up this, you see it will be 100%. Class, are you following? Class, are you listening?
Yes, sir.
Okay.
Yes, sir. We are following.
So actually, I'm looking at the time factor. Let's not
Yeah,
overboard.
because we have exceeded all our time.
Yes,
but
yes. Okay. So thank you very much for this, and to this we call it a day. Except if there are questions, then we will take them briefly. Thank you.
So, Mr. Bonji, I have a
Yes,
so
sir.
if they are to work on, so they've now understand what descriptive and inferential statistics is all about, and we've given them some idea on how to work simple descriptive analysis, and in terms of their data analysis, when they are presenting in their dissertation, what are the points they need to take note of when they are making their presentations?
Okay. So should I take this, or another student was trying to
No,
ask a
just go
question?
ahead.
Okay. So yes, when you come to applying this, that's what she's saying in Excel. How do we apply this in real when you carry out your project at this stage project? We encourage you to go with the quantitative data. So it's the simplest you can do, and for trial for the first beginners in research. So when you start with quantitative, at the point that you apply your descriptive and inferential statistics, I think we need to clear that. When you have collected your data, the least you can do is to describe. And when you are describing, you are stopping at the level of mean, median, and the mode. Mean, median, and the mode, and at best, the standard deviation of the distribution, the range, and the variance. Somebody will stop his work there and keep explaining and capitalize all his findings around that measure of central tendency. If you understand what I've said now, I've already mentioned measure of, descriptive statistics, the mean, median, mode, and then standard deviation, variance, and what have you. Somebody will describe all his findings around this and conclude his finding. Actually, go back and retrace your step. In that your work, there was a place you captured as hypothesis. Now you cannot use descriptive statistics to answer hypothesis, because hypothesis is a statement of proportion. And being that it's a statement statement of probability, you are already talking about the population, not about the sample. So if I want to use the descriptive statistics, I can only use it to describe my sample, but not population. So if you want to talk about the population, then bring the hypothesis into perspective. And the hypothesis, how you answer the hypothesis is through use of inferential statistics. Now, in your inferential statistics, you use the outcomes under your descriptive statistics, which are the measures of central tendency and dispersion, so that you can now calculate the parametric test or non-parametric test. Take, for instance, t-test. Why we carry t-test is for us to know whether there is difference in terms of the population, not in terms of the sample this time around. But we are deriving what we use from what we are supposed to use. We derive them from the descriptive statistics, which is the mean, median, mode, standard deviation, variance, and range. When you have these parameters, you now input them into this formula. Your outcome on the t-test is talking about the population. You remember we carry out inferential statistics to forecast on the population. By doing that, that is the main what we call analysis, because that's the end part of the statistics. So after summary, which is descriptive statistics, you need to take it further. Now, when you are doing this discussion and giving out your findings in your report, you should be able to say the population of HIV people living on this state was found to have this average age. But there are differences between the male and female. Now, that's where you now talk about your outcomes in inferential statistics. What are your outcomes? The outcome shows that, yes, there was difference. But was this difference significant enough? You remember that there was a place we call level of significance. So after your inferential statistics, you are going to arrive at one answer, whether it's significant or not significant. If it is significant, that means there is something we call the p-value, because after t-test, you are going to use the t-test value to get the p-value. If you are conversant with publications, you see they always talk about p-value, p-value. So the p-value is for you to make decision. What is the p-value of your findings? Sometimes you see them, they write 0.00001. That means it's too small. It is telling you the level of error in this research is far too low, less than 0.05. So your yardstick for comparison is called level of significance, which you selected as 0.05. If you have a p-value of less than 0.05, you say that your work is highly significant. The lesser your p-value, the highly significant it is. But once it's higher than 0.05, it means most of your findings are based on error or probability. So you cannot stick to it, you cannot hold water. So when you are reporting, you now say, I found out that the difference was highly significant with p-value of 0.001. By that, you have answered your hypothesis. Your hypothesis says there was no significance, but your finding is now saying it's significant. Vice versa, if your p-value is higher than 0.05, you will now say your findings, the difference is not significant. For that instance, go to hypothesis again. You see that your null hypothesis was saying that there was no significant difference between this group and that group. Now, because your p-value says is higher than 0.05, you now say, yes, you accept the null hypothesis. There is no significant difference. When you are explaining that, you have concluded and it's making sense about the entire population. You have been able to infer. That's why they call it inferential statistics. You have also been able to forecast about the population, even though it was a sample that you used.
Thank you, Mr. Bonji.
Yes.
Okay, I think this is one of the longest classes we've ever had. It's understandable because it's data. Statistics is very wide. So we also need to let you guys know also that in analyzing, you need to analyze in accordance with your objectives. And in your presentation, you need to make that clear. cannot just say because you have done analysis, you just present table. It has to be systematic, and you need to give reasons for everything you are doing. It's very important. All right, so I wish we can have a part B where we do thorough practical, but unfortunately, we have restricted timetable on the program. And then we can see your participation is also dwindling. So we don't know why, but we're just trying our best to do as much as we can. I hope we have learned very well from today's class. If we have questions, we can send in questions to admin. He will forward them to Bunji. If there is the responses, we'll send them to the general group. Okay? But you can also go to YouTube to learn more about this data analysis. You've had a first-hand experience. If you need to actually learn more, how do I calculate my standard deviation, my variance, my proportion, just go to YouTube and you'll see many videos that will help you. All right. Do we have any housekeeping issues that we need to address? Jerry, Tolu. Okay, so while we're doing that, Mr. Bunji is going to send the activity for the week, okay? Something to just juggle us a little bit, so that to show that we actually have an understanding. So we just wish everybody a beautiful week. We're sorry we had to take this long. I hope it's worth it at the end of the day. So please kindly fill your attendance evaluation form. And this attendance evaluation form, you notice that we keep sending you the analysis by school. The reason is because we're cooking something this year, and the representation of the school is actually important, because it will also speak to the hard work of some of the lecturers. So when we are cooking something, then it's these statistics that will inform our decision making. So thank you very much, everybody. We really appreciate you. Thank you, Mr. Bunji. That was really, really comprehensive. Thank you so much. So we wish everybody a pleasant week ahead. If Tolu and Jerry, if they don't have any other information, have a blessed week. God bless us all.
All right, thank you very much, ma'am.
Thank you, everyone.
Thank you, Ma.